So today is going to be the next video on my custom computer architecture. So if you recall in the last video, I went over the basic instruction set that I would want my computer to have and how it would execute its instructions. So right here, I wrote a C program in online GDB, but it's written in C. And basically, this program is a very simple emulator, and it will allow me to test the programs and the instructions that we have. So just to go over the instructions, we have halt, add, subtract, store, load, branch if zero, so that's the conditional, input, output, bitwise and bitwise not. So as you can see, all of these instructions are held within a switch case, which is held within a while loop. So how it works is it's basically while halt is not true, which is while the program is running, what it is going to do, it is going to get the opcode from the ROM, and the address of the ROM is specified by the program counter. And that's another thing we have here. So we have the opcode is from the address in ROM specified by the program counter, bit shifted by 4 bits. As you recall, we're working with 8 bits, and it's a 4-bit computer really, so these 4 bits, the upper 4 bits, these are going to be the opcode, and the lower 4 bits is going to be your data. And you can see we're going to bit shift this by 4 to get the opcode, and the data is, we're just going to AND it, and that will give us the other 4 bits. So here's a print statement to print the current program execution, but that's commented out. And yeah, so then we're going to switch the opcode, and we're going to execute which particular instruction which we want to execute. And then we are going to go back through the loop, and I guess we just have to look at these instructions, and what these do is they're going to perform the instruction, increment the program counter, and break. And that's what it does. Except for halt. So if we get a halt, halt is equal to 1, and we're breaking out of the loop, and we're going to break out of this loop, and the program is done, which is what the instruction we want to do on actual hardware. For add, we're going to add the accumulator equals the accumulator plus the data specified by the, we're using the data here as a pointer to a RAM address, and whatever is in that RAM address we're going to add to the accumulator. Same with subtract, we're going to do that just with subtracting, so we're going to subtract whatever is in the specified RAM address from the accumulator. That's your basic arithmetic operations. With that, you should be able to do division by repeated subtraction and addition and multiplication by repeated addition for integers, really only, unless you want to specify for other things. Store, what this is going to do is it's going to store the accumulator in the RAM address. So if we want to load something else in the accumulator, the current value can be stored into RAM. That's what it does. And then same thing, we increment the program counter. For load, we're going to load the data specified in address to the accumulator and then increment the program counter. For branch, this is going to allow us to do a loop. The program counter is just equal to the data, and that will allow us to do that. And then we have this, which is branch if 0. So this is the one conditional which we have here, and this allows us to do while loops, for loops, if statements, anything that requires a branch in program execution. That's what this is going to handle. And if we want to make it do, like, to implement an if statement or a loop, we're going to have to use instructions so that this could be used. And what that's going to do is if the accumulator is 0, then it's going to branch to the specified data. I don't know why I put this -1 here. I'm not sure why that's there, but that was there when I wrote this. Then this instruction is just empty. And we have input. So this is going to, in the actual hardware, what this is going to do is it's going to read from the input register. So how it's going to work is that the user or whatever can write anything to the input register, and this instruction will just read it. But of course, we don't have that hardware, so what this is going to do is it's going to use scanf in place of that, and this print statement is here just for convenience. So is this really. What we really want to do is just load in something in the accumulator, and this is how we do this. This does have certain limitations. We're basically just emulating the CPU and the RAM. We're not emulating any I/O hardware really, so we're just using printf and scanf in place of that just because it's easy. Here we have the output. It's kind of the same as this, except we're going to output right to the output register, and that's what it would be in hardware. But since we're not on hardware again, we're just going to print whatever is in the accumulator to the output and increment the program counter. Then we have bitwise AND. It's just going to bitwise with the RAM data, and then not. That's a simple instruction. The data does not matter for this. So, and then we have this one. This is going to be an exclusive OR, I think. Yeah, that's what it says. And one instruction we don't have here is to load data. So I know it's kind of confusing, but this data is mostly being used as a pointer. So you could see the RAM specified by data. So this is going to point to a location in the RAM, which is specified in this array. But we can't have an instruction right here that will just be like accumulator minus data. It's accumulator minus RAM data, or accumulator plus the value stored in RAM, which is that specified by this. This is the address. So another instruction we could have is we don't need to have to rewrite this. So to have it be accumulator minus data, which would just be like this. Just to see, we don't have to write separate ones for this because we could just have another instruction somewhere that would load the data into the accumulator, which is like accumulator equals data. That would be another instruction which we have. But yeah, this is pretty limited because we only have 16 instructions that we can do, just because there's only 4 bits high, 4 bits low, and it's shared. But this should work as a computer. It should be able to do everything that a normal computer could do, just much worse. So let's actually run the program. And this is the ROM. So this is the read-only memory. This is what you would program into it. You'd write this in C for a normal computer or assembly. But we don't have an assembler either. So what we're just doing is we're just specifying machine instructions by this integer array. And what this program, this is the very simple program, what it's going to do is it's going to load input into the accumulator, store that input in an address, and then it'll load another input, store that, and then it'll load another input, and then it will add whatever is in here, which is whatever you entered, to whatever is the accumulator, which is whatever you entered here. So it's basically just taking 2 inputs, adding them together, outputting it, and then another thing you're going to do is you're going to branch back to 0. So enough talking about this, let's actually try to run this. And it's going to say enter input, so let's say 3. And then we're going to enter another input 5. Output is 8. 3 plus 5 is 8. Yes, basic math. So let's try 1, 3, 4. So as you can see, it is looping. It is implementing a loop, and really what that's doing is it's just saying we're okay, go back to this loop, and we're not going to reach halt, because there actually isn't a halt instruction. I don't think that's here. Either way, let's try something else. Let's try 45 and 23. 45 and 23. Output 68. Now, look at this. This is not an accurate emulation, because this is a 4-bit system. So if we actually tried to do this, it would overflow on the actual hardware. But since we're just using the C instruction with our modern computer, it's just adding them together, when really we're going to be using a 4-bit adder circuit, and that's not going to have any idea to do with numbers this big. It won't even take them. It will take, like, if we try to add, like, for example, if we try to add like 12 and 12, it will be able to take 12 because that could be represented in 4 bits, but this would overflow. But like for this one right here, you can't enter this; it would overflow. So that's not accurate to the real hardware, which is what it would be. Just very limited based off of 4 bits. Yeah, so this is our basic emulator right here. And yeah, so this is the update for our custom computer architecture. One thing that I want to do is I actually want to have it so you could write an assembly program and have that in a text file, and instead of writing manually to this array, it'll just read from a text file, and that'll make the interface a lot easier. But yeah, it does seem to do what we're looking to do, and notice how we can't stop it. So if we want to stop it, we actually have to do that, since it is an infinite loop. If we don't want an infinite loop, we have to use this. So yeah, that's what we have here. Thanks for watching.